Okay, so hello everyone. My name is Philippe Milot. I'm a developer at Audiokinetic. I'm part of the Wwise SDK and runtime development team. So today, I'm very happy to show you the progress we've made in supporting web audio in the Wwise product. So very quickly, we're going to go through exactly what Wwise is for those who don't know. And this is actually a long-running project for us. We've been working on this since even before 2019. But in 2019, we had a pretty big push for development, and this is kind of a follow-up to that. So I'll be explaining that in more detail. Then we'll go through an actual live demo of a game using the product. And then I'll explain exactly why this is so difficult to make it happen. Then we're going to go through the same demo again, but this time with the Wwise profiler connected so that you can see under the hood what's happening with the sound engine. And then again, a technical overview of why it was so difficult to make the profiler connection. And finally, I'll close with some feedback about the development experience, because we're not typically a web development company, and this is kind of a first foray for us. So we have an outsider point of view for this. And of course, time for questions at the end. So Wwise is an interactive audio solution. We're middleware, and it's very popular in the games industry. And it's a product that has many parts. So there's an authoring tool that is used by a sound designer. So it's a visual tool so that they can design the soundscape of their game without writing lines of code. There's an integrated profiler inside this authoring tool so that you can connect to a game and see in real time what's happening under the hood. Of course, there's a runtime part that's integrated inside the game. So that includes a sound engine, a spatial audio engine, interactive music, and a collection of DSP plugins that like various reverbs, flanger effects, and stuff like that. This runtime is integrated in a game using a C++ cross-platform SDK. And we have ready-made integrations of this SDK for Unity and Unreal Engine. And today, so I'll be able to show you basically all 5 parts, except for the Unreal Engine part, but the Unity part. So why should you care about this? Wwise is used in the games industry a lot, also outside of it, but games is the main business. It's used by very small studios. You have very large games like Ratchet & Clank and Assassin's Creed using it, but also smaller indie games like Firewatch or Limbo, Rocket League, stuff like that, using it. And the reason why it's so popular is because of how many platforms it supports. So you can see here, we support every mobile platforms, every desktop platform, and all major gaming platforms, even VR. But as you can see, there's one glaring omission, and it's web. So that's what we're trying to fix here. We want to treat the web platform as just another one of these, because you can actually run games on the web, and it works. So this is, as I said, this is a long-running project. For those who attended the W3C workshop on web games back in 2019, we showed a functional text-based application demo. So it was integrating the sound engine and showing off all the different parts just in a visual, in a text-based menu. And it was using preloaded assets. So that means you had to download the entire game assets up front before you could launch a game. So that was not ideal. But we put this project on ice because there was some uncertainty regarding shared array buffer and security in browsers, and also because the audio worklet node was not fully supported in every browser at the time. So fast forward to 2022, those are no longer problems. So what we want to do now is take this project and make it much farther, take it much farther. So compatibility with Unity, have a way to stream assets instead of downloading everything up front, Wwise profiler support, and basically treating the web as any of our other platforms with automated builds, packaging, and testing. So I think that's enough talk. I'll launch the game so you can get a feel for it. Okay. Maybe take this down a bit just so that it doesn't explode the speakers. Okay. So this is for those of you might have seen this before, because this is the Wwise Adventure game. This is a project we use to basically teach the Wwise integration in Unity. So it's used in the certification process for a while. So we took this project and basically exported it to Wwise using a build of for WebAssembly. So let's start. And as I play, obviously, pay attention to the way the sound and music reacts to the user input. Right now, we're outputting a stereo mix just because it was easier to set up for the room. And so if things are set up properly, you should hear the sound panning around as the camera is moving.
Hello, adventurer. Our village has been struck by a plague of... Can you help me save Allegro Kingdom?
I'll skip the dialogue so we can...
I believe I have... I remember placing... Why can I not retrieve it myself?
Looks like the panning isn't quite set up for this room, but it doesn't matter. I'll still be able to show the rest. We'll move forward, and as I cross the bridge, please pay attention to the music. You're going to hear a transition because this is using the interactive music system of Wwise. So these transitions can be programmed on actual bars of the music, so it's easy for a musician to program. And when I say program them, I mean programming them in the visual tool, not writing the program. And as I approach a thread, you'll hear other segments of the music being layered in. And when I eliminate the thread, it comes back. So pretty simple stuff. Let me skip forward to a different segment. Oops, sorry, I forgot something first. Going too fast. So first, I'm going to enable spatial audio so I can show you a part of the game that is designed to showcase spatial audio. And so the reason why this is a special area of the game is that we set up the scene in Unity so that it sends a simplified version of the geometry that you see here to the sound engine, so that the spatial audio system can actually compute the way that the sound of the different emitters bounce around in the walls and ceilings of the scene. So it's not like it's not just a plain reverb DSP effect. It's actually computing the sound waves. So let's see. I'm going to place an emitter right here.
Greetings, adventurer. I heard you'll be venturing into the woodlands.
And as I move around, you'll hear the
parts.
sound of the emitter change as it's being occluded by geometry and diffracting around corners of the geometry.
And the dark plants had already taken root. Luck alone saved me. I may make implements of battle, but I'm no warrior.
Diffraction
as
around
the
this
evil
corner.
sent a ball of venom my way. I turned to flee, and my sword swung on my belt, deflecting the poison.
So that gives you an idea of what Wwise is usually used for. So I'm going to close this for now and show you why this was so dang hard to make it run on the web. And a lot of it has to do with Unity. So let's go over threading. For those who saw my talk in 2019, you might remember that was the main subject, and it's still an issue in 2022, unfortunately. So where is this coming from? Okay. Yeah, exactly. It's a reflection. Yeah. So back in 2019, we had this working. So the sound engine starts and manages multiple threads to do its work. So there's an audio thread doing the audio rendering. There's a separate bank thread to manage the assets generated by the authoring tool, and there's an I/O thread to basically manage the I/O requests from the other threads and pipelining them in an efficient way. And all of this, we made it work back in 2019 on the browser by using an abstraction that's provided by Emscripten. So Emscripten, the SDK that can take C++ code and generate WebAssembly with it, allows you to use the pthreads API that you use commonly in desktop platforms to manage threads, and map those threads onto web workers. So the way it works is Emscripten is going to set things up so that when the application starts, there's a web worker pool that's allocated. And when you start a thread using the pthreads API, one of those web workers from the pool is taken, and it will instantiate the same WebAssembly module that the main thread is using. And although it's instantiating a separate instance of this module, it will reuse the same memory heap from the main thread because it's backed by a shared array buffer. And that's why shared array buffer was such an important part of our solution back then. And once you have this shared heap, then it becomes easy to have thread synchronization using the atomics operations that are available in browsers. So that's the way it worked. It worked fine back then. The problem is that Unity does not support any of this. So we had to go back to the drawing board because when C++ code is compiled using the Unity build system into WebAssembly, it's not compiling down the atomics operation into actual WebAssembly atomic operations. And it's not supporting the pthreads abstraction at all. It's not even generating a build that will be backed by a shared array buffer. It's just a plain array buffer. So we had to take this solution on the left, that's what we have running on most platforms, and turn it into this, basically. So it's a truly single-threaded version of our entire sound engine. Of course, there were some corner cases, like, for example, we had our bank thread sometimes waiting on an audio rendering pass because it wanted to unload some assets, but there were still sounds playing. So those corner cases had to be dealt with. Basically, we're no longer waiting on anything, and the bank thread might actually do an audio rendering pass itself. But yeah, this was not easy to do, but eventually we got to a point where it works as a single thread, and we are sharing the same CPU time as the other as the rest of the game, including the graphics rendering pipeline, which means that if the game actually skips a frame, or if it slows down somewhat, then we do have audio starvation pretty quickly. The audio will drop out. So it's not an ideal solution, but right now through Unity, this is pretty much the only way to go. So I'm going to run through the same demo that we just saw, but this time I'm going to connect the Wwise profiler so you can actually have a better idea of the workflow of using Wwise. And of course, all of this will still be from the browser. So let's make this smaller. Okay. So on the left, I have the game. On the right, there's the Wwise application with the Wwise Adventure Game project loaded in. So I'm going to connect the Wwise application to the game using the profile. And now what we have now that we have a connection, you can see, if I go back to the designer view, you can see here the meter is actually metering the actual output of the sound engine. So you can see right now we're outputting a stereo mix. And this is what's going into an audio worklet node on the web API side. So I'm going to switch to the main profiling view. So you can see on the left, we have a series of API calls that are being made by the game. But on the right, you have a voice graph. So this voice graph allows you to see what's running, all the sounds that are playing in real time right now. So we have music playing, going into music buses. One of them has a room verb effect on it. Those buses are mixed into a non-world bus. At the same time, we have some ambient woodland sound playing in a loop. This is going into a world bus. Those two buses are then mixed together into a master audio bus, and this is what's coming out to the web audio API. Okay, so as I start the game, you'll see this voice graph update in real time. And of course, this is a real game, so you have a lot of stuff going on at the same time. So this can get unwieldy pretty quickly, especially with short-lived sounds popping in and out. So what I'm going to do is I'm going to filter by a container called music region, so we only look at the music for now. So as I approach the village, you'll be able to hear the music change, another music transition, and you'll actually see it in the voice graph at the same time. So right now it's strings and bass playing. I'll increase the volume again. And now clarinet, violin, flutes, like this. Okay. I'm going to approach the enemy we saw before, so I can show you another detail you might have missed the first time around. Oops, sorry. I forgot to move forward in the quest. Okay. Yes, I'm cheating. Sorry. I'm a cheater. Let me cheat some more and make sure that I don't die accidentally while demoing. Okay, so this plant is throwing a projectile, and there's a Doppler effect on this sound. This is a Doppler effect that's computed in real time by using a high-pass filter and pitch shifting. You can hear it as it zips past the camera. So let's look at this Doppler effect in real time, okay? I'm going to switch to the voice profiler view here to inspect and remove my filter and use the filter for the projectile instead. And now I'm trying to inspect it, but it's a short-lived sound. So when I select it, it goes away very quickly. So what I'm going to do instead is go back in the timeline, which is being recorded, to a time when the projectile was being played. So right here. And now it's no longer showing stuff in real time. It's frozen. And I can select the sound that was playing at that exact moment and actually inspect it and all the properties being affected by it in real time. So you can see, sorry, it's not the right one, this one. So there's a high-pass filter, various changes to the voice volume, and a low-pass filter that's not active right now. And now let's go to the designer view and select this sound so I can show you how it was set up. We can see here Doppler effect is a game parameter. So that's the numerical value that the game is sending and saying just how far or how close the projectile is to the camera. And so on this game parameter, we have bound two RTPCs. So these are real-time parameter controls. One affecting the high-pass filter and one affecting the voice pitch with curves on the values. So what's nice about the profiler is that you can actually change these in real time. So I'm going to solo the sound so that you can hear better. So now we really hear that Doppler sound. And I'm going to exaggerate the curve. So now it's really stupidly exaggerated. And with the other sounds, yeah, it sounds ridiculous. So let's dial it back. That's better. So that's the idea. So that gives you an idea of how you can use the tool to change tweak the soundscape in real time. And it's always better to do that while hearing the entire environment. Okay, so let's switch to the spatial audio demo. And now I'll show you another view of the profiler. Go back to the live mode, so it's no longer frozen in time, and switch to the game object profiler view. Remove my filter and choose the main camera to focus on, and I'm going to follow it. So now we have a 3D view that's updated in real time, and it's showing the geometry as the sound engine sees it. So as I said, it's a simplified geometry that's only used for audio computation. So you can see here the locations of every emitter in the game right now, positioned in 3D space, and as well some portals in 3D. So these are the ones that are taken into account for the computation of reflections. So I'm going to put my emitter down again.
Greetings, adventurer. I heard you'll be venturing into the woodlands.
And
word travels fast in these parts. You would best be careful.
Here in this view, it's a bit hard to see, but you can actually see the paths of the reflection from the radio emitter that I just put. So I'm going to filter it so that you can see it better. So I'm filtering for the radio, and I'm going to change the view so that it's from the top.
I turned to flee, and my sword swung on my belt,
on this.
deflecting the poison.
So now it's from the top. As I move around, you can see the yellow and pink lines representing respectively the direct paths to the sound and the reflection paths. And what's super nice about spatial audio is that you can have multiple levels of fidelity. So right now in this game, we have up from first order to fourth order of reflections. So I'm going to use a hotkey to switch to increase the number of reflections progressively, so you can hear and see the difference in real time. So please pay attention to the audio. So this is first order. I'm going to switch to second order.
In precision, you may also be able to deflect
and you can see the added reflections.
Here you are, adventurer. One hearty pickaxe
third order
will serve me well when mining ore.
And fourth order.
I heard you'll be venturing into the woodlands. Word travels fast in these parts. You would best
also,
be
I
careful.
forgot to show you the diffraction around the corners in the portal, so let's do that with fourth order. So you can see here the sound waves are not going directly; they are going around the corner here to my camera, and this has an effect, of course, on the filtering and the positioning of the audio.
Here you are, adventurer.
Obviously, this kind of fidelity can take its toll on the CPU, and not all games might have enough room to support that. So what we can do is go to go back to the main profiler view and go to the CPU tab, so you can actually see the percentage of CPU that's taken for different parts of the audio simulation. So here, reflect is showing the percentage of the CPU taken just for computing the reflection. So right now it's sitting at around 4 to 5% of a game frame. And if I go back down to first order, it's back to about 1 or 2%. So that's another use for the profiler, is just trying to strike a balance between audio fidelity and performance. So that's about it for the demo. And now let's talk about how we made this work. And this is what I call reversing the connection. because in every other platform that we support, this is the way this is done. So we have the game actually binding and setting up a UDP port and a TCP port and acting as a TCP server. And so the UDP communication is made for discovery. So the authoring tool is going to send a request via UDP on the network and try to detect every game instances running on the network. The game will reply via UDP, giving the TCP connection information, and then you can connect with the profiler using the TCP port. Obviously, this is not possible on the web for security reasons. You cannot bind these ports. So what we decided to do was set up a proxy server. So we prototyped something in Node.js for now, and it's working pretty well. It's a WebSocket server, so that when the web version is launched, it will connect automatically to this proxy server. And then from that time, every time that there's a BSD sockets operation that would normally happen, what it will do instead is wrap this BSD sockets operation in a descriptor JSON object, send it over to via WebSocket, and the proxy server itself is going to perform the operation. So it's a low-level abstraction. So in essence, the proxy server is binding the UDP and TCP ports. What's nice about this solution is that we didn't have to do anything to change the networking on the authoring side. The authoring side basically just sees the proxy server as the game, and that's it. Another thing that's nice about this solution is that if there are multiple instances of the game running, each one is going to have a separate WebSocket connection to the server, obviously. And the proxy server is going to manage the ports individually for each client connection. So you could have 2 tabs of the game running, and the authoring tool would still see 2 separate instances of the game. Or in a more likely scenario would be that you are sharing the same proxy server for your entire studio, and every developer is using it. So with that, we have feature parity with the other platforms for the profiler. And as you saw, the proxy server did not add any noticeable latency. Obviously, the latency requirements for this are pretty low. So in essence, it worked out pretty well as a temporary solution. So in conclusion, some feedback about the development workflow. Coming back to web after a 3 years hiatus, we were really happy to see that shared array buffers is finally back. Audio worklet support is now rock solid across multiple browsers, including the audio worklet node. We were really, really amazed to see Dwarf support in the Chrome debugger. So for those who don't know, Dwarf is a format for debugging symbols. So we were able to actually break into our C++ code and step through our C++ code from the Chrome debugger. And we could even use it in the profiler of Chrome, so we could see which C++ function was taking too much time. Just amazing, compared to the printf debugging that we had to do in 2019. And also, even Unity support for WebGL is now very strong. So it was really easy for us to port the Wwise adventure game project. And it just, except for the audio, of course, it just took us a few days of work, and it was good. Problems that we ran into mostly has to do with the toolchain, mild annoyances with the toolchain. It has a very aggressive linker pass, even more so than other platforms based on LLVM. So it was stripping our exported symbols from our DSP plugins. We basically could not use any DSP plugin until we put a hack in on the Unity side to generate C++ code that would use those symbols and force the linker to recognize that they are useful. That was an annoying hack. We also ran into a bad code gen for some of our DSP functions that introduced a high-pitched hiss on our low-pass filter. That was really not desirable. But of course, the real problem, as we saw earlier, is that we are not leveraging the audio worklet high-priority thread. Because we want to focus on Unity compatibility, we are stuck Unity will not allow us to do that. So that's a problem. But also, even if Unity did support exporting with a shared array buffer memory, there's also a problem at the Emscripten level where the generated JavaScript isn't necessarily compatible with the environment that Audio Worklet gives us. So Emscripten will always be able to generate a JavaScript file that can run on the main browser thread, on a web worker environment, and even Node.js. So these are all supported environments, but Audio Worklet is not supported officially. And sometimes it's using APIs that are not available in the Audio Worklet global scope. I've seen some people doing hacks at the link phase and post-link phase to make this work. But the problem is that we are middleware developers. All we can do is create libraries and ship them to people so they can use it in their game. So we don't control the final linking phase of the project. So those kind of hacks are non-starters for us. So it would be really nice if we could work together with Unity, the Emscripten team, to finally fix this problem. Because, yeah, real games need a high priority thread. We shouldn't have audio drop out when a game misses a video frame. But even so, right now, this is the state of things. And we do think that it's good enough for actual real world use cases. So I'm really glad to say that next year, we're finally going to ship support for web as a real supported platform. So also another thing I want to mention is that we don't necessarily need to wait this long to try this technology. Right now, since we're in the development right now, we are looking for partners to actually try this technology early in a real world situation. So real games, real interactive audio experiences. Doesn't need to be games. And we want to make sure that what we're building actually works for you. So yeah, if you're working on a game right now and you're looking to export to web, or if you're making a web-only game and you're using C++ or another native platform to do your development, just talk to us and maybe we can actually work something. But yeah, this is pretty much it. Thank you for your time, and I hope we have questions.
Thank you, Philippe. So Philippe was every week or nearly every week with the Web Audio Working Group. So he was part of the evolution also of the standard. So do you have any questions?
Those hacks and edits to the Unity engine that you mentioned, would it be possible to implement those as a Unity plugin or add-on? Is it?
Yes, we made those hacks as part of our Unity plugin that takes care of integrating the Wwise SDK into Unity. So yes, if you have a Unity project, you'll get that temporary workaround automatically.
Yeah, thank you very much. It's always nice to have a demo of Wwise. It's a great engine, and I'm very happy that Audiokinetic is part of the sponsors of the conference. Now, apart from making your engine work on the web, which is great, yes, I'm still hungry. What is there any further thing that you think could happen together with the web audio community that is now possible, which is beyond having the web as another deployment platform for games you support? Is there any exchange you think will be possible in the future?
Yes.
Bits of code, concepts, and so on.
So I might have two parts to my answer. So the first one is that, yes, Audiokinetic is part of the community group that helps work with the Web Audio Working Group, and we do give feedback. And part of the feedback has been a lot about running like C++ WASM applications and making them run in Audio Worklet. And as I mentioned, there's still some parts that could be improved. So I think part of this could go all the way to the spec and actually making sure that, because we're not the only ones with this use case, right? So it's any audio application that is built on C++ or stuff like that are running into the same issues that we are. So we're hoping that we can help improve the spec to fix those use cases. That's the first part. The second part is maybe on a more immediate future is that so there's a part of Wwise I didn't show because we don't support it yet on web, but we do support object-based audio on some platforms. So actually sending out separate audio signals as individual signals to a spatialization platform that's external to us. And we were thinking of doing that on web by using the 3D panner node of the web audio, and actually have the positional, some elements being positioned in space using the panner node. So once we get there, we'll might have more feedback about how to make this node more usable or stuff like that. Thanks.
Any other question? Yes.
Yes. Maybe I didn't understand anything, but at the end, you said you could not use the audio worklet?
I could use, okay. Right now we are using the audio worklet, but it is pretty much wasted. All we do is copy a buffer. And that's the only thing we do as part of the process callback. We are basically taking the Wwise application is going to generate a pretty large buffer that has higher latency, but still okay for games. So usually it's 4 buffers of 1024 samples, for example. But that's configurable, of course. And then the audio worklet node is just going to take this buffer and just take 128 sample chunks at every callback. So yeah, kind of wasted for a high priority thread, but that's what we can do right now.
I have a question. Okay, this is a commercial product, but we can use Unity to generate application and deploy them on the web. We can use it with my students. So for non-commercial applications, it's free.
Yeah, it's free to use. But even smaller projects, it's free to use.
And second question, I think I talked with that. I chatted with you a while ago. It's a shame David left, but my students are using Babylon.js. That is a web specialized library for making games and so on. And that is, by the way, I'm making advertisement for Babylon because my students love it and it's easy to learn and fun to play with. So my question that I asked you was, do you think it is possible to use this audio engine with such a library? I mean,
with Babylon.js, I guess that depends on the actual use case of the game. But my thinking is that it wouldn't necessarily be the most natural choice right now, because so the Wwise has a C++ SDK, right? So we don't actually export JavaScript, a JavaScript API. So usually it's more usable from within either a ready-made game engine that allows you to write C++ code or native code, and that's kind of the use case we're in. And whereas if you're coming from a game engine that's strictly JavaScript, you're not necessarily going to have a direct access to the Wwise API. You're going to have to write a native shim to call the APIs.
Okay, thank you. So any other questions? Yeah, another one.
Yeah, thanks a lot. Besides the fact that the web could be a really nice platform for developing and pushing some new games, how do you think this could be also a way for inventing new scenarios between users?
Like, I'm sorry, I didn't get the question.
Yeah, do you think besides the fact that the web is a new platform for you to develop and pushing your new games, what are the constraints for you and the ideas to maybe build something new between users for building new scenarios between them? Are there any things in the web that you could do maybe that you could not do natively? I mean, with all the web around and data, are there any ideas about that?
I mean, yes, but for Wwise, it's middleware, right? So we're not actual end user application. So we just give a tool to help other people build the end user application. But something like what you described, like connecting people together, and could be using Wwise, but where we don't like, it's basically it's a sound engine that allows you to bind parameters that are controlled by the client to audio effects and reactions. So yes, you could use that to build something like what you described. Have I done an audio-only project? You mean using Wwise or? Well, the closest thing we did was the integration demo, the text-based demo that you saw a screenshot of earlier. But if you're asking if you can use Wwise without WebGL Canvas, yes, absolutely. It's just in the end, it's just a WebAssembly library that you can integrate however you want. Oh, actually, that reminds me, there was actually another internal project that never saw the light of day, but we did have at some point a prototype for a store, like an asset store, where you could preview the assets using the Wwise Audio Engine, and that had no visual support. That was just a prototype that we did at some point.
Well, I don't know if some of you were at SMC 2022, but we had some demonstration of virtual instruments using VR, written with Unity or written with the Unreal Engine. And the guy was also using some libraries for generating sounds and making effects. So I think this can be maybe applied also to something else than games, but things like that, or experiences with visiting, I don't know, 3D landscapes or whatever, or installations. Or
I mean, there's a lot of features I didn't have time to show, but yeah, there's a lot you can do with this.